Okay, I want to show you probability for a few minutes. Probability and combinations, where maybe you have to make two things be true for your problem to solve. So let's suppose I have a bag of marbles. I have 4 blue, 3 green, 6 yellow, and 7 red. All right? And I ask you, what is the probability that you will reach in the bag and draw out a green marble? Well, I have 3 green marbles. Probability is always, you do the desired outcome. Okay, so what you want to have happen, the desired outcome out of the possible outcomes. Okay, sometimes it's desired or favorable, all right? So what we want to have happen, the favorable outcome is 3, because we want green. So I have 3 chances that I get a green. Out of how many possibilities? Well, I have to add them up. 4 plus 3 is 7, plus 6 is 13, plus 7 is 20. So I have a 3 out of 20 chance of getting a green marble. Suppose I asked you what would be the probability that you draw a blue marble. Well, there's 4 possibilities that I would give that, 4 potentials. Remember, we added it up out of 20. Now, this is one of those things that you're going to look on and you would say, I know I did this right, and this isn't one of my choices, one of the answer choices. It's because this reduces. You can put it in your calculator, do the numerator denominator button, and put it in, all right? And if you hit enter, it'll do it for you. But this is going to reduce because there's a 4 divisible on both of these. 4 over 20 is the same thing as 1/5. So that would be the answer on there. So remember, I've told you, if you feel like you've done everything correctly and your answer isn't one of the choices, look and see, wait a minute, is there a different way I can say this that means the same thing? Maybe that's what it is. So that could certainly happen in this situation. All right, so that's all there is to this when you're just doing the single probability like that. So let's just change my numbers to make sure we're good on this. Let's suppose I have 2 blue, 4 green, 1 yellow, and 3 red, okay? Suppose I want to see how many chances I have that I would draw a yellow, the probability of a yellow. Well, I have 1 chance out of 2 plus 4 is 6, 7, 8, 9, 10. So I have a 1 out of 10 chance that I would draw a yellow. Now here's what happens sometimes when they give you a combination problem. And they would say, what is the probability that you would draw blue first and green second with your second draw? Now, they're going to tell you, this is very important, they're going to either say with replacement or without replacement. And here's all they mean by that. Let's start with the first piece of this. What's the chance that I would draw a blue first? Well, there's 2 out of 6, 7, 8, out of 10. This is going to reduce to 1/5. So my chances of getting a blue, I have a 1 out of 5 possibility of getting a blue. Okay? Here's the thing with the green. If I put that blue back in there, well, how many chances do I have of the green? I have 4. If they say with replacement, that means I put that back in there. So how many possibilities would I have? 10. 4 out of 10, okay? And that's going to reduce to 2/5. So we multiply them. It's going to be 1/5 times 2/5 is going to give me my answer, which is mean I would have a 2 out of 25 chance of getting blue first, green second, with replacement. All right, so here's what this is saying. This is the catch though. What if they say, what's the chance that I get a green the second time without replacement? That means I didn't put the blue back, all right? Well, if I don't replace the blue, and I already drew 1 out, if I don't replace whatever I drew first, then I'm down 1. So I only have 4/9 of a chance that I get green second. Okay? So I'd have a 4/9 of a chance for the green if I don't replace. And the way you always solve combination problems is by multiplying. So do 1/5 times 4/9. I take each possibility, the possibility for each piece, and I multiply them all together, and that gives me my total. So your calculator will do this, but I can tell you that is 4/45. So I have 4 out of 45 chance that that's what's going to happen. If they gave my answer to me in decimal form, I would just hit those 2 arrows above the enter sign, and that would create it into a decimal, okay? So let me do one where I don't, I can't reduce it. That will help, I think, with seeing it. Let's suppose I want to draw a red first, and then yellow with my second draw. Okay? The red first, I have a 3 possibility out of, how many total? 10. So for my red, I have a 3 out of 10 possibility of that. Okay? Let's suppose if they say with replacement, then what's my chance on yellow? I have a 1 out of 10 possibility with replacement. So it would be 3/10 times 1/10, which is, I have a 3 out of 100 possibility that it's going to work out that way, okay? If they said without replacement, then what's my chance on yellow? I have a 1 out of 9, because I only have 9 marbles. I didn't replace whatever I drew first. It doesn't matter what color it was. I'm not replacing, so I only have a 9 possibility on the second. So it would be 3/10 times 1/9, which is going to be 3/90. And that's going to reduce. Your calculator will do this. I'd have a 1 out of 30 chance that was going to work out. Okay, again, your calculator's going to do that, so don't panic. It'll take care of that for you. I just want you to see the other things. So here's a problem I've heard before that could show up. Suppose you're flipping a coin. What is the chance that you get heads? Well, there's only one side with heads, right? 1 out of 2, right? 50-50 chance. So 1 out of 2 chance you get heads. What's the chance you get tails? Same thing, right? All right, so let me show this really plainly. What is the chance that you flip a coin 5 times and get heads every time? Okay, so the first time you flip the coin, what's the chance of it? You got a 1 out of 2 chance, right? The second time you flip the coin, what are the chances? It's 1 out of 2, isn't it? Just starts over, right? Third time, chances, 1 out of 2. Fourth time, 1 out of 2. Fifth time, 1 out of 2. And remember, when we're doing these combination problems like this, you multiply. You do not add. I've seen them give you a trick answer before where they've got the adding. They're just making sure you know. Nope, we multiply them all. So, hang with me. I wanted to show you one simple thing. 1/2, this would be 1/2 to the 5th. Okay, because I'm multiplying 1/2 5 times. Or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have a 1 out of 32 chance that I could flip a coin 5 times and get heads 5 times. Okay? Let me show you one other problem like this that comes up with these combinations and probability problems. Suppose I have a lock, and I've got to set my lock for my new bike, and they tell me that I have a 4-digit code. And each number is from, I can use any number from 0 to 9 for each digit. And I can use the same number 4 times. So if I want to make my code 0000 and get my bike stolen, I can do that. Okay, well, so how many possibilities are there for my first digit? 10, because look, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You gotta count 0 because it could have been one of your digits. 10. Well, I said I can use the same number twice, so how many possibilities are there for the second one? 10. How many for the third? 10. And how many for the fourth? 10. So I would multiply all those together, and look at this, it's 10 4 times. That is, guys, 10 to the fourth. That's how many possibilities there are for my bytecode. And I'm just going to tell you, just because 1, 2, 3, 4, 10,000. There would literally be 10,000 different possible codes, okay? Because I could use them and duplicate them, but I might not. It's just giving me the option. Suppose they do not give me the option. They say you can use each digit only once. How many possibilities are the first one? 10 still. But how many for the second one now? There's only 9 for the second one now. Because whatever I use the first time, I can't use it again. How many for the next one? 8, because I can't use those 2 digits again. And how many for the next one? 7. So the total possibilities is whatever 10 times 9 times 8 times 7 is. That would be the number of possibilities I would have for my bytecode. One other kind of problem I want to show you that's along these lines is how many possible, making up a problem, how many possible meal combinations could you get? Our snack bar, we have 3 kinds of sandwiches, 2 kinds of chips, and 4 drink choices. We've got Coke, Diet Coke, Dr. Pepper, and water. Okay, whatever. How many different possibilities are there? You just multiply the possibilities. I have 3 possible sandwiches. I have 2 possible chips. And I have 4 possible drinks. 3 times 2 is 6 times 4. I have 24 different possible combinations. All right? Let me make it simpler so I can prove this to you. Let's just say I have 2 different drink choices. So I'm telling you the rule. It's multiply again. 3 times 2 times 2. 3 times 2 is 6 times 2. So I have 12 different meal options. So let's look at this. I'm going to say sandwich A is bologna, okay? And then I have, let's say chip 1 and pop. I'm going to say I'm just making this up, obviously. We're going to say we have bologna, ham, and chicken, right? And our drinks, we have pop or we have water. And on chips, I'm just going to call them 1 and 2. All right? So I could have bologna, chip 1, and pop. I could have bologna, chip 1, and water. I could have bologna, chip 2, and pop. I could have bologna, chip 2, and water. I could have, we'll put it down here. There's 4 choices there, right? I can do the same thing there with ham. I could have ham, chip 1, and pop. I could have ham, chip 2, chip 1, and water. I could have ham, chip 2, and pop. I could have ham, chip 2, and water. So 4 more choices, right? All right, let's do it with my chicken sandwich. I could have chicken, chip 1, and pop. I could have chicken, chip 1, and water. I could have chicken, chip 2, and pop. I could have chicken, chip 2, and water. So 4 more. So 4, 8, 12. So see, it really does work out. But all I need to do is just multiply my different options, and that will give me my answer. Very important though, keep in mind when you're asking any of these probability questions, as I showed you, you're talking the desired outcome out of the possible outcomes. So pay attention to what they're asking for. Make sure you count the possible outcomes. I know that sounds simple, but you run into different situations sometimes. You got to just pay attention to the information and see, okay, what is the total amount that we're talking about? So count up all of the marbles or all of the meal choices or whatever the options they give you, and do you want the desired outcome out of the possible outcome. If it's a combination, you multiply the probability of each one. Oh, last thing, a die, I know we call them dice, technically the singular is die. What are the chances that if I was going to flip a typical die, I would get a 3? How many sides are there on a die? 6. What are the chances that I would get a 3? 1. I have a 1 out of 3 chances of getting a 3, right? Suppose I did this. What are the chances that I flip it and I get an even number? Well, when I flip the die, there's 6 possibilities. How many even are there between 1 and 6? 2, 4, 6. So I have a 3 out of 6 chance of getting an even number. Do you notice 3 out of 6? Does that reduce? You did it all correctly, and you go, oh no, my answer's not right. Put it in your calculator and see. But 3 out of 6 is 1/2. Right? I got a 50-50 chance of getting an even one. Again, if I said, what are the chances that I get an even flip the first time, and I get a 5 the second flip? Well, my chances of getting an even flip we just saw are 1 out of 2. My chances of getting a 5, well, I said that we agreed that there are 6 possible outcomes. How many chances are there for a 5? Just 1. 5 shows up on one side, right? So I have a 1 out of 6 chance for that. So I multiply them. 1/2 times 1/6. Your calculator will do it, but it's 1/12. So I would have a 1 out of 12 chance that I would get any even number the first flip, and I would get a 5 the second flip.